This is a video for Edexcel Further Pure 1, Coordinate Systems 2, the Ellipse and Hyperbola, Section 2.2, Equations of a Hyperbola. Well, a hyperbola is the final one of the conic sections that we've been studying. We've seen the ellipse and the parabola, and now the hyperbola is the one where the cone is cut by a plane which is of slope greater than the slope of the cone itself. So we then get two branches to a hyperbola. We've already studied the rectangular hyperbola, but now we're going to look at something called the hyperbola, which has a general equation: x squared over a squared minus y squared over b squared is equal to 1. So similar to the ellipse where it was plus y squared over b squared, the hyperbola is x squared over a squared minus y squared over b squared is equal to 1. Well, here we have a GeoGebra file which allows us to look at the hyperbola, which has got equations x squared over a squared minus y squared over b squared equal to 1, and I can vary the values of a and b. But firstly, note that a gives us the vertex here of the hyperbola, two of them, one at negative a and the other one at positive a on the axis. If I change a, then that will move the position of that vertex. It's really stretching the hyperbola in the direction of the x-axis. Similarly, if I change b, that will stretch the hyperbola in the direction of the y-axis. So a and b change the shape of the hyperbola. You'll notice that as the branches get further and further away from the origin, then they're approaching straight lines. So those straight lines are going to give us what are called the asymptotes. I'll just draw them in freehand as best I can. So we have one coming along here, going through the origin, which is close there, and the other one coming in this direction. Again, it should be going through the origin, and these are the asymptotes of the hyperbola. And what I want to do now is to see if we can work out what the equations of these asymptotes are. So as x and y approach infinity, in other words, we're getting further and further away from the origin, then the 1 in the equation becomes insignificant. And so we get that x squared over a squared approaches y squared over b squared. And that means that y is equal to plus or minus bx over a in the limit. So just rearranging that equation there to give y as the subject, we get y is equal to plus or minus bx over a, and these are the asymptotes. So we have here y is equal to bx over a, and this one here is y is equal to negative bx over a. The other fact that we had was that the hyperbola crosses the x-axis at x equal to negative a and x equal to positive a. So just repeating that, the asymptotes are y is equal to plus or minus bx over a. Now if a is equal to b, then that means that y is equal to plus or minus x. And if that was the case, then the asymptotes are perpendicular, and then you have what's called the rectangular hyperbola that you've already studied. Let's now look at an example of how that might be used in an exam question. So in this question we're asked to sketch a hyperbola which passes through 4, 0 and has asymptotes y is equal to plus or minus a half x. So the first thing we want to do then is on our axes is to put in the asymptotes. So we are going through, for example, 2, 1 gives us a slope of a half, and obviously negative 2, 1 gives us the other asymptote. So those are the two asymptotes. We also know it crosses the axis at 4 and negative 4 therefore, and so the hyperbola is going to look like this. Approaching, it's difficult to draw on the computer, but approaching these asymptotes rather than touching, of course. We know that y is equal to plus or minus a half x is the asymptotes, and therefore a must be equal to 2k and b equal to k. But of course we know that a is equal to 4, and therefore b is equal to b is equal to 2, so that the equation is x squared over a squared, which is x squared over 16, minus y squared over b squared, which is y squared over 4, is equal to 1. So from that little bit of information we'd be able to sketch the hyperbola and also to give its Cartesian equation. There it is, neatly presented, so just take a little bit of time, maybe pause the video and look through that so you fully understand how we've managed to do that. Well, moving on now, I want to consider the parametric equation of a hyperbola. If we have x is equal to plus or minus a cos t and y is equal to b sin t, you notice these are very similar to the parametric equations for the ellipse that we looked at, where we had a cos t and b sin t. So you can see here a link between the sine and cosine functions and the hyperbolic functions, and then the equations of ellipse and hyperbola. If we have that, then x squared over a squared is equal to cos squared t, and y squared over b squared must be sin squared t, and subtracting those, cos squared minus sin squared, so x squared over a squared minus y squared over b squared is equal to cos squared t minus sin squared t, and that is equal to 1. So these give us the parameters x is equal to a cos t and y is equal to b sin t, defining the hyperbola. For those parameters, then t is any value at all in the real numbers. An alternative set of parameters for the hyperbola, so the hyperbola has two different sets of parameters that you can use. An alternative set is a sec theta and b tan theta, and in that case theta lies between negative pi and pi. So it's worth checking through and making sure that you understand that those parameters also give you x squared over a squared minus y squared over b squared is equal to 1. In the second example then, we're asked to sketch the graph of the hyperbola with the given parameters x is equal to plus or minus 2 cos t and y equals sin t. Well, immediately from those parameters, the first one, x equals plus or minus 2 cos t, implies that a must be equal to 2, and the second one we have that b is equal to 1, and therefore the asymptotes are at y is equal to plus or minus b over ax, so that's 1 over 2x. In other words, y equals plus or minus a half x. I can draw those in on the graph, going through 2, 1 for y equals a half x, and negative 2, 1 for y equals negative a half x. So those are the asymptotes. The value of a is 2, so we know that the hyperbola crosses the x-axis at +2 and -2. And once we've got that, then we can sketch in the hyperbola being asymptotic to those two straight lines and going through the values of 2 and -2 on the x-axis. With the value of a equal to 2 and b equal to 1, then its Cartesian equation is very simple: x squared over a squared, so x squared over 4 minus y squared over b squared, that's just y squared, is equal to 1. So there it is, written out neatly for you, and a much better sketch graph than I can do on the computer. Well, that completes this particular video, and in the next one we'll be looking at something called the eccentricity.